Hello everyone, welcome back to my channel. This video is on the topic of balancing redox reactions using the oxidation number method. Redox reactions, which involve simultaneous oxidation reduction, can be balanced by two methods. One is the oxidation number method and the other one is the ion electron method. So in this video, we'll go through the steps that are involved while balancing a redox reaction using the oxidation number method. So let's start. Okay, so let us have a look at this reaction. That is the reaction of copper metal with dilute nitric acid. Products are copper nitrate, nitric oxide and water. This is a redox reaction, and in this video we will see how this equation can be balanced using the method that is the oxidation number method. The first step that is involved in this particular method is we write the oxidation number of each element that is involved in the group. So we start with the first element, copper, which is in the form of copper metal. The oxidation state of copper is 0 here. Then we have the second reactant, nitric acid. So one by one let us write the oxidation state of all the elements. Hydrogen is +1. Nitrogen is +5. That's because oxygen here is having its common oxidation state of -2, and this -2, when you multiply it by 3, it becomes -6. So therefore -6 + 1, nitrogen is there in the +5 oxidation state. We go to this compound copper nitrate, where again nitrogen is in +5, oxygen is -2. There are two nitrate ions, so each nitrate ion is having a charge of -1. -1 into 2 is -2. Therefore, copper here is in the +2 oxidation state. Nitric oxide, oxygen -2, nitrogen +2. And of course, we have the third product, water, where hydrogen is in +1 and oxygen is -2. So looking at this oxidation states, we can clearly see that the change in oxidation state is copper from 0 to +2 and nitrogen from +5. Nitrogen in nitric acid is +5 and in nitric oxide it is +2. The next step essentially talks about we have to identify the elements undergoing the change in oxidation number. Copper from 0 has become +2, that is, it has undergone oxidation, and nitrogen in nitric acid was +5, this has now become +2. So let us look at the next step, which talks about balancing the number of atoms which have undergone oxidation and reduction. We know that copper has undergone oxidation, so as you can see there is one copper atom on this side, one copper atom on this side. Nitrogen in nitric acid has undergone reduction from +5 to +2, so that is also balanced as there is one nitrogen in nitric acid and one nitrogen in nitric oxide. So this step has been completed. As it is mentioned here, the atoms undergoing oxidation and reduction are already balanced. Let's look at the next step, which says that we have to find out the number of electrons lost and accepted. Copper, which has undergone oxidation from 0 to +2, has donated 2 electrons or have lost 2 electrons. Nitrogen from +5 has become +2. So there is an acceptance or gain of 3 electrons. So oxidation reaction is involving 2 electrons. Reduction reaction involves 3 electrons. The next step would be to equalize the number of electrons. That is done by multiplying the reactions with appropriate coefficients. So to equalize the number of electrons, I'll multiply the reaction of copper with 3. That will make the number of electrons 6. Same way, I'll multiply the reaction of nitrogen with 2. so as to make the number of electrons 6. So the number of electrons have been equalized. In the earlier step, we have determined the coefficients to balance the number of electrons or to equalize the number of electrons. Therefore, copper is multiplied by 3, nitric acid with 2. So copper nitrate therefore has to be multiplied by 2 and nitric oxide by 2. So these are the coefficients that we get after equalizing the number of electrons. Now as soon as we multiply the reactants with the appropriate coefficients, let us count. Copper on the reactant side is 3, product side is also 3. Nitrogen on the reactant side, there are only 2 nitrogen atoms. But on the product side, if you see, the number of nitrogen atoms is 3 into 2, 6 plus 2, 8 nitrogen atoms. That means we will have to just do a little further balancing over here to equalize the atoms undergoing oxidation reduction. So to make 8 nitrogen, as I said, there are 2 nitrogen on the reactant side and 8 nitrogen on the product side. So I will multiply nitric acid by 8. Rest remains the same, 3 copper nitrate and 2 nitric oxide. So now nitrogen on the reactant side is also 8, product side is also 8. So with this step, so as per the earlier step, all the atoms have been balanced except hydrogen and oxygen. So we move on to this step where we first try to balance hydrogen. There are 8 hydrogen atoms on the reactant side, only 2 hydrogen atoms on the product side. So to make that 8, I'll multiply water molecule with 4. When we do that, 8 hydrogen on the reactant side, 8 hydrogen on the product side, hydrogen is balanced. Look at the number of oxygen atoms. Oxygen is 8 into 3, 24 oxygen atoms on the reactant side. And if we go to count the number of oxygen on the product side, this is 3 into 2, 6 into 3, 18 plus 2, 20, 24. 24 oxygen atoms even on the product side. So oxygen also has been balanced. So if we look at the reaction now, it appears to be a balanced reaction. And if we now look at the reaction, this is how the entire complete balanced reaction looks like. 3 copper plus 8 HNO3, 3 copper nitrate, 2 nitric oxide, 4 water molecules, all the atoms, all the elements which are involved in the reaction have been balanced. Thank you for watching this video and do subscribe to my channel by clicking on the subscribe icon. Thank you.